In this video, we will see how to create land use and land cover classification in Google Earth Engine. So let's get into it. First, we will make our region of interest. For that, you can use this point, polygon, or rectangle button. Let's use this rectangle, draw a rectangle button, and draw a rectangle to select our region of interest. We have drawn a rectangle. Now let's click on this exit button and let's rename it as RY, that is region of interest. Now we will load Landsat 8 image collection for our region of interest. First of all, we have made one variable called the Landsat collection. In that variable, we inserted one image collection from Landsat 8 to a layer. If you want to know where this Landsat 8 snippet comes from, you can search here Landsat and you can see this is USGS Landsat 8 collection to tire on to reflectance. Let's click on this. Here you can see the collection snippet. You can copy from here, paste. Also you can search for band and image properties from here. Now let's close this. After that, we filtered the collection for the year of 2024. Then we filter bounds with our ROI. It filters only those tiles which falls within this ROI region. Now we need to clip each image to remove any part that is outside of ROI. For that, we used a map function which iterates throughout the collection, one image at a time. It takes the first image and clip to this ROI, then second image clip to this ROI, and so on and so forth. Now we will make a cloud-free composite for Landsat collection. For that, we will use Landsat simple composite algorithm. Here we have defined one variable called composite, and in this variable we compute the simple composite algorithm of Landsat, which is ee.algorithms.landsat.simplecomposite, and we pass this collection as collection parameter, and as float is true. If we defined as float as true, then float values will be retained, and if we defined it as false, then the float values will be converted to nearest integer value. This algorithm creates a cloud-free composite image from this collection. Now let's add this composite image to our map and see how it looks. For that, we use map.addLayer function and pass our composite image as the first parameter, and then bands B4, B3 and B2, those are RGB bands of the Landsat image, and pass the minimum value as 0 and maximum as 0.3. We can adjust these values later, and then wrote the name of the image, or if we want we can make it composite. Now let's run the code and see how the composite image looks like. Run. The composite image has been loaded. To remove our ROI rectangle or hide this, just uncheck the geometry or uncheck the ROI. So we have successfully loaded our Landsat composite image. Now we will define our land cover classes and make the training points for each class. we will use the property name as land cover, and today we are going to classify three land cover classes: urban, vegetation, and water. And value starts from 0. We will define urban as 0, vegetation as 1, and water as 2. First, let's create the urban land cover class. For that, go to geometry imports and new layer. For creating training samples, we will use points today. So click on this point. Now beside this geometry, go to these settings. It says edit layer properties. Here in the name text box, we will write urban, the name of our land cover class, and import as geometry we will use feature collection, and then add a property. The property name should be land cover, and value for urban we will use 0. The first value starts from 0, and this is the property for land cover classes. So for every land cover classes we will use the same property, that is land cover. Then we can select a color. Let's select red as urban, and then OK. Now let's zoom into built up area and make some training points there. Let's make some point in the urban area. Okay, we have made 25 points. Now let's go for our second land cover class, that is vegetation. So create new layer and go to edit properties and write the name of our land cover class, and then feature collection and add property. Property should be land cover, and now the value is 1. For vegetation we should go for green color, and OK. Now these are vegetation, we can select here, and for better visibility you can turn this composite image off and turn on the satellite base map, so it will be much easier to select the vegetation. We can turn on our composite image or the RY to see the boundary. Here are the croplands. The cropland should also go to the vegetation class, since we do not classify the cropland as a separate land cover class, so it should go with the vegetation. We have already selected 50 training points. Now let's go for the third option, that is water. So go to new layer and edit properties, rename this as water, and feature collection property land cover, and value should be 2, and water color, let's make it blue. Okay, now make some training points for water. Try to select from all part of your image, so that variation or various types of signature is collected. So we have collected 30 points, and I think those are enough for the classification. Let's exit this. Now let's check the feature collections. Those are all our feature collections. 3 feature collection: urban, vegetation, and water. Now we will merge all 3 feature collection into a single feature collection. We made a variable called new FC, that is new feature collection, and in this new feature collection we merged all 3 feature collection and put it in this variable. We wrote urban dot merge. Merge is the command for merging 2 feature collections, and within the merge we wrote vegetation. That means vegetation feature collection will be merged with urban and then merged with water. So 3 will be merged together. Landsat image has many bands. We will only select the RGB, near infrared, and shortwave 1 and 2 bands, those 6 bands for our classification. We have written all 6 bands, that is B2 for blue, green, red, near infrared, shortwave 1 and shortwave 2 bands, and put it within a list, and then keep it in a variable named bands. The property of the sample points was land cover. Let's make the property name a string and keep it in a variable. We defined a variable named class property, and the value of class property is the property name of our sample points. Now to generate the training data, we make the sample in our composite image. We have made one variable named training, and in this training variable we keep all our training samples. For that, first we have written our composite image, and then select the bands we have selected, the 6 bands, these, and then sample region. The sample regions algorithm will make the training samples of all bands in our composite image based on the collection and class property we provide. So in the collection, we wrote the name of our merged collection, point collection, and in the properties we have written the class property in a list, and the class property value is the property name we have written, that is land cover, this one. And Landsat image has scale of 30, so we have written the scale here. Now we will make a classifier. Here we use the smile random forest classifier. The code is e.classifier.smile random forest, and here we use number of trees 50. You can change this based on your demand. And variable per split, mean, leaf population, back fraction, and see these properties has been used the default values. You can change these properties as well. And then train the classifier with the training features that we made here. And then class property is land cover, and input properties are our bands. Here one thing we should keep in mind that when we make a training points, then the properties is a list. So here class property goes under a list. But when we make the training for the classifier, their class property is just a string, the name of our class property, not a list. We should keep this in mind. Now we will classify our composite image. For that we need to write composite.classify and pass our classifier, and we put this classified image under a variable called classified, and then we center our map, and then finally we add the classified image to our map. So map.addLayer classified, minimum value is 0 and maximum 2, since we have 3 classes, 0, 1 and 2. And then as a palette we run 3 colors: red for urban, green for vegetation, and blue for water. Now if we want to print some info about the classifier, this is optional step. We can print classifier.explain, and this is the text we want to identify the classifier. Let's run the code and check how it looks. Here we are getting the classifier explanation. The classified image is loaded here, and the random forest classifier is explained and printed here in the console. We can expand and check. There are 3 classes and ban values, number of trees, out of bag error estimate, and other things are written here. If we want to hide the training points, we can uncheck this one. Now let's check our classified image. We will increase the transparency so that we can see what is behind. Let's turn off our composite image and see the satellite base map. So this is the satellite base map, and let's see how our classified image looks like. The classification looks good. If you want more accurate classification, you need to take more samples and more land cover class as well. Now if we want to do some accuracy assessment, we can make a random column. Here we have made one variable named with random, and make a random column in our training dataset, and then we want to split by roughly 70% and 30%. For that, we made a variable named split, which is 0.7, and make two partition of our training samples. One is training partition and another one is testing partition. So training partition will be less than 0.7 value, so which should be roughly 70%, and testing partition will be greater than or equal 0.7, so it should be around 30%. Then we have made another classifier, random forest classifier, with our training partition dataset. So in the features we have passed our training partition, and everything else is similar to the previous one. Now with our trained classifier, we will classify the testing partition. In Google Earth Engine, a classifier can classify image in multiple bands, and it can also classify any sample points like testing partition or any feature collection. And now for the accuracy assessment, we can create a confusion matrix and print it. For that, first we made a variable named confusion matrix, and here we put the error matrix from our test variable. So test dot error matrix, here class property is the actual value of the test, and classification is the predicted value of the test. So it will compare the actual value and the predicted classification. The classification is automatically made when we classify with any classifier. And finally, we will print our confusion matrix. Let's run the code. If we see the confusion matrix, we can see that most of our sample points are correct, but here one is wrongly classified. How to interpret this confusion matrix? Let's see 0, 1, 2, and horizontally 0, 1, 2. That means this one is for urban, this one is for vegetation, and this one is for water. And the first column is for urban, second one is for vegetation, and third one is for water. First, there are 7 samples in urban. 6 of them are correctly classified as urban, and 1 is classified as vegetation. So it is wrong. And second row, that is vegetation, 16 samples were there. All of them were correctly classified. And in the third row, water samples, there were total 8 samples. 8 of them has been correctly classified. And if we see our image, we can see most of the area is correctly classified. So if we need more accuracy, then we should increase our class and also the training samples. Thanks for watching.